Lesson 10-4, Infinite Geometric Series. Objective: find the sum of an infinite series. Write repeating decimals as fractions. We are going to look at an infinite geometric series, which means there's an infinite number of terms, not like what we've been having before, which is a partial sum. We want to determine if this infinite geometric series is convergent, which means that we are getting closer and closer to one particular number that has a sum, or if there isn't a number it's getting close to as far as a sum as we call it divergent. So let's take a look at an example of that we have a convergent series. Let's take a look at a common ratio less than 1. So it looks like we're timesing by a half each time. So the first partial sum is the number 5. We graph 5. So a sum of 1 is just 5. If we do the second partial sum, which means we add just the two numbers, we're going to get 7.5. The third partial sum means adding the three numbers, we're going to get this number. And if we continue to add, the partial sums look like they're getting closer and closer to one particular sum, and we say that is going to be a convergent series. Now, when the common ratio is greater than 1, we start with 1/16, and here's our first sum. Our second partial sum is adding the first two terms. That's going to be a little higher. The third partial sum will be adding the first three numbers. This will be the sum. And the fourth partial sum and the fifth partial sum. And it looks like the more terms we add, the higher and higher the sum becomes, and the sum does not approach a finite value. We call this a divergent series. Let's take a look at whether this infinite geometric series is convergent or divergent. Now notice the numbers are getting smaller, and so that's a good sign. What we want to do is we want to figure out what the common ratio is. So I'm going to use these two numbers. That's a little easier for me to look at. 81 divided by 243, and I can see that is 1/3. So this is multiplying by 1/3, and the same thing is happening over here, multiplying by 1/3. So our common ratio is 1/3, which meets the requirement that the common ratio has to be less than 1. So we say this is convergent. So in other words, this will have a sum. All right, let's determine whether this infinite geometric series is convergent or divergent. Now, notice that the numbers are getting larger, and that's not a good sign here. So it looks like the common ratio is timesing by 5 halves. And then this will be 5 halves as well. So R is equal to 5 halves. And in order for something to be convergent, the ratio, the absolute value of the ratio has to be less than 1. So the answer is divergent. In other words, there is no particular sum. It looks like it's just getting larger and larger without bound. Your turn. Here's the answer. Your turn. Here's the answer. All right, so let's take a look again at this idea of partial sums, but instead with a graph, let's look at just a list. So here's our infinite sequence, and here's our first term, and the first term is our first sum. If I add the first two terms, that's what we call the second partial sum, and that adds up to 3/4. If we add the first three terms, that's the third partial sum, and that adds up to 7/8. If we add the fourth partial sum, that looks like it's adding up to 15/16. So the partial sums can be written as a summation notation. They all seem to have this idea of adding powers of 1/2, and they're associated with this term 1/2 to the n. So let's go ahead and take a look at that particular problem. Now, we know that if you have an infinite geometric sequence where the common ratio is less than 1, this is the formula to give you your sum. It's as simple as knowing the first term and knowing the common ratio. Just put it into the formula, and this will give you your sum. If your common ratio is greater or equal to 1, it has no sum and we can't find the answer. Okay, so let's take a look at this summation notation and see if we can understand what's going on here. I like to rewrite this as 1/2 to the k power instead of writing it this way. So this will be 1/2 to the 1 power plus 1/2 to the 2nd power plus 1/2 to the 3rd power, and on, and we're just going to keep multiplying like that. Okay, so I hope you can see that to go from here to here, your common ratio is going to be 1/2. Okay, since 1/2 meets the stipulation of a converging geometric series, we can go ahead and find the sum, and it'll be taking our first term, which is 1/2, and then taking 1 minus our common ratio, 1/2. So this is going to be 1/2 over 1/2, and the answer is 1. And if we go back to the previous slide, it looks like that's what's happening. It looks like this sum is getting closer and closer to the number 1. All right, let's go ahead and do another number. We want to find the sum here if it exists. So we have to figure out what the ratio is. So it might be difficult for you to figure out the ratio from here to here, but maybe from here to here you can see the answer. And it looks like I'm multiplying by a -3. And sure enough, to go from here to here, it looks like I'm multiplying by a -3. So our common ratio is -3. And this does not meet the stipulation right here. So the absolute value of the common ratio isn't less than 1, so there is no sum. This is divergent. Let's take a look at the next example. And in the next example, again, it really depends on whether we can find our common ratio. So if it's hard to tell on the first two, go to these two, and it looks like I'm multiplying by a negative number, and it looks like I'm multiplying by -1/2. And it looks like over here I'm multiplying by -1/2. And that's what looks like was happening at the beginning as well. Now r is equal to -1/2, and you can see that its absolute value, if I were to take the absolute value, that would be less than 1. So the answer is that we can find the sum. So let's go ahead and find the sum. The sum will be the first term, which is 3, over 1 minus, and then the common ratio is -1/3. So this is going to be 3 over 2 negatives in a row. That's 4/3. And this is 3 times the reciprocal, 3 over 4. And so the answer is 9 over 4. Your turn. Here's the answer. Your turn. Here's the answer. Let's take a look at evaluating with some summation notation. And so let's figure out what our first term is. And our first term is, if I put k up here, this will be 0, so 1/2 to the 0, and our first term is 5, plus 5 times 1/2, plus 5 times 1/2 to the 2nd, and then plus ... So that's how we write it up. Our common ratio is this number that's being taken to each power, 1/2. So this is going to meet the stipulation here. All I got to do is now substitute the numbers in. Our first term, 5, 1, take away 1/2. So this is 5 over 1/2. And when you times by the reciprocal, that answer is going to be 10. Your turn. And here's the answer. Now our last objective is to write this 0.25 repeating as a fraction. So method 1 is to write this out as a sum. So what we can do is we can say 0.25 plus 0.0025 plus 0.000025 plus dot, dot, dot. So what's it going to take to go from here to here? You got to multiply by 0.01. And from here to here, you got to multiply by 0.01. And so on. So it looks like my R is 0.01. And 0.01 does meet the stipulation of absolute value less than 1. So I can go ahead and find my sum. My sum will be my first term, which is 0.25, all over 1, take away 0.01. So this is 0.25 divided by 0.99. Multiply each by 100, top and denominator by 100. And so 25 over 99 is the decimal that represents. Method 2 is to use some algebraic properties. And so I know that this is 0.25252525 dot, dot, dot. So I'm going to let this be x. X is equal to this. I'm going to write it this way. And what I want to do now is I want to get one of the patterns in front of the decimal. And to do that, I'm going to times by 100. 100x will be equal to, when I multiply this by 100, there's going to be the 25 will move in front, and then I'll have the 25, 25, 25, dot, dot, dot. I'm going to put the x underneath it, which is 0.252525 dot, dot, dot. And I'm going to subtract. And that'll be 99x. And then when you subtract these two, it'll be 25. And these decimal parts will be removed. So the answer is 25 over 99. Okay, pick out whatever method you like and find the answer. And here's the solution.